how to create a cost-effective Hyper-V cluster, step by step. Hello, my name is Greg Shields, and I'm a partner with Concentrated Technology. And I want to spend a little bit of time talking with you today about really Hyper-V and how you can use some of the native Windows tools to connect Hyper-V in a high availability architecture. Now, Hyper-V is a great tool because Hyper-V enables you to incorporate virtualization into your data center using the tools and the operating system components you already have in place today. Hyper-V requires Windows Server 2008, and if you have Windows Server 2008 in your infrastructure, well, you have all the software you need in order to create Hyper-V right now today. Now, the problem with Hyper-V is that the way in which you go about creating high availability with Hyper-V is through the use of Windows failover clustering. Now, Windows failover clustering has had sort of a sordid history in Microsoft's long history of products. When it first came out a number of years ago, Windows clustering was fairly painful to implement and required a lot of extra hardware, which made it somewhat costly to actually develop. Now, these days, especially with the release of Windows Server 2008, Windows failover clustering has gotten dramatically easier to work with and dramatically easier to implement. One of the primary goals with Windows failover clustering and Windows Server 2008 was the ability to create clustering without needing expensive consultants. The idea here is that even a technology generalist could be able to create Windows clustering. Now, this is a good thing because Hyper-V relies specifically on Windows failover clustering to accomplish its high availability goals. Now, one of the tools that you can make use of for actually creating a high availability cluster with Hyper-V is, for example, StarWind Software. StarWind Software develops an iSCSI-based software target for actually connecting servers into a software-based SAN. If you remember, Windows failover clustering requires some sort of shared storage that all of the hosts in the cluster can actually talk to, communicate with, and store their virtual machines on top. Now, that central storage has a lot of different options that you can use for deploying it today. It can be hardware-based, or it can be software-based. A lot of hardware-based iSCSI stores are relatively expensive to deploy, which sometimes make it difficult for actually incorporating Hyper-V in a high availability architecture. As an alternative, StarWind provides a software-based SAN that installs to existing hardware in your environment, existing Windows servers in your environment, to allow you to use that as the central storage for your Hyper-V cluster. In this case, what it allows you to do is use a relatively inexpensive solution for creating that necessary high availability. Now, the ways in which you go about creating that high availability is by essentially installing the Windows failover clustering service. You install the Windows failover clustering service and all of the bits that it needs in order to make sure it functions, and you connect that Windows failover clustering service to your StarWind iSCSI SAN. This iSCSI SAN may be on a server somewhere in your environment. You'll see here that I've shown in the lower right-hand side of the screen a picture that depicts two Hyper-V servers, Hyper-V1 and Hyper-V2. These Hyper-V servers have three different network connections that are required in order to create this cluster: a production network connection, a private network connection, and an iSCSI network connection. Using the StarWind software-based iSCSI target, you can create single connections to iSCSI disks, or even MPIO-based multiple connections or team connections to those iSCSI disks. The goal here is to create as much high availability into your high availability architecture. What I want to do now is I want to spend some time showing you the step-by-step process for actually creating clustered Hyper-V. If you've deployed Hyper-V in your environment today, this is probably a pretty strong goal for you. You wish to use something like failover clustering to ensure that the loss of a single host in your environment doesn't also mean the loss of all of the virtual machines in your environment. Now, doing this involves 4 steps. Step 1 is actually configuring the StarWind iSCSI target software. This is a relatively easy process because the StarWind iSCSI target software is very easy to configure. I'll show you the exact processes you'll need to go through to complete this step. Once you've completed this step, we need to actually attach the Hyper-V hosts to the StarWind iSCSI target. As you'll see in this picture, we have 2 different hosts that we will connect to via remote connection to show you how that process works. This will involve configuring the iSCSI initiator software that's natively available on both of these hosts. Once we've successfully connected into our iSCSI disks, we'll then be able to configure Windows failover clustering. For Hyper-V to work with Windows failover clustering, the cluster has to be created first. And so what we'll do is create that cluster and then finally configure Hyper-V to migrate virtual machines over to that cluster so that we can successfully run those virtual machines on the cluster itself. Let's start by dragging over a remote desktop from another server in this environment. You'll see that this other server has the StarWind software already installed to it, and it's currently up and available. You'll see that we've connected to localhost on port 3260. This is a common port used for iSCSI target connections. And more or less, StarWind is ready for us to begin creating those drives that will be used as part of our cluster. Now down here in the lower right of the screen, you'll see that the StarWind icon can be used to actually start the management or do some preference changes or even adding connections if you want. What we want to do first is go to this localhost connection and right-click and choose to connect. By default, the StarWind username and password are both set to the word test. Once we log in, we actually have the ability to create new drives based on this connection. If I right-click on localhost once again and choose to add a device, I can go ahead and add a device as necessary for the Quorum drive and also for the virtual machine drive that we're going to be using for Hyper-V. Now the type of device that we want to use is an image file device. If I choose an image file device and select Next here, it gives me the options of mounting an existing virtual disk, creating a new one, or creating one based off of a snapshot. In this case, I'm going to create a new virtual disk. The size of the virtual disk that I want to create is 512 megabytes. This is standard Microsoft philosophy for Quorum drives. And you'll see that my virtual disk location is here under C and my profile on the desktop in a folder called Hyper-V quorum.img. You'll see there are a couple options here for that disk as well. I can compress it, encrypt it, or even fill it with zeros. I'm not really interested in any of those for this instance. If I choose the Next button, I'll have a few other options that I can select as well. Again, here's the virtual disk I want to make available via iSCSI. I have a couple of different options as well. You'll see asynchronous mode, read-only mode, and allow multiple concurrent iSCSI connections, as well as some advanced options. The most important check marks to have available for this Quorum drive is asynchronous mode and also to allow multiple concurrent iSCSI connections. These are important because as a cluster, the multiple cluster nodes are going to need to connect into this iSCSI target to actually use the data that's on that target. So I'll keep those two checkboxes checked. If I choose the Next button here, I can choose a target name. Again, this is the Quorum drive, and I want to make sure that that is available for me when I try to connect to it later, so I'll name that target name Quorum. Choosing Next actually completes the Add Device wizard. And Finish Again actually completes the creation of that disk device. You'll see now that I have an image file here with name of Quorum and type image file. Now this completes the first half of the different disks that we need to create for our cluster. This is just the Quorum drive. We also need to create a second device that we'll actually use for storing the virtual machine. Again, it's an image file device, and I'm going to create a new virtual disk. But instead of quorum.img, I'm going to name this vm.img. And I'm going to give it a much larger size, let's say 25 gig instead of 256 megabytes. Other than that, all of the configurations are pretty much the same as what we did with the first one, making sure that asynchronous mode and making sure that concurrent iSCSI connections is available to us. If I choose the Next button again, I want to choose a target name. In this case, that target name will be VM instead of Quorum. Choose Next, and then finish the process. Once we've completed this process, you'll see that I now have two image files that correspond to two different disks that will eventually be used by this cluster. The first is the Quorum drive, a smaller disk. The second is a VM drive that's large enough that I can host a single virtual machine on that drive. If I go ahead and minimize the StarWind console for a second, you'll see this Hyper-V folder that was used for actually storing those disk files. Here's one about 512 meg in size. Here's another one that's about 26 gig in size. This is the VM image. These two IMG files are what are actually used by StarWind for the creation of those disk drives. Now that we have our disks configured, the next step is really attaching our Hyper-V hosts to our StarWind iSCSI target. I'm going to drag in another remote desktop here. And you'll see in this second remote desktop we have Server Manager that's up. I'm going to choose the Start button and go to Administrative Tools and bring forward the iSCSI Initiator. Now I want you to be aware that this is a Windows Server 2008 R2 instance. This R2 instance has a slightly different iSCSI Initiator screen than what you're used to seeing with Windows Server 2003 or even Windows Server 2008, the original RTM version. When you first start the iSCSI Initiator, you'll see that it will tell you that the Microsoft iSCSI service is not running, and it is required to run for iSCSI to function correctly. In this case, you really need to start the service now and have the service start immediately each time the computer restarts for iSCSI to really function. So in this case, we choose yes. Once we've chosen yes, this brings forward the iSCSI initiator control screen. And once again, if you're used to seeing the control screen from Windows Server 2008, the original version of Windows Server 2008, you'll notice there's a new screen here called Targets that allows a quick connection. If I choose in the target that I've created for the server where that target was created, I can actually quickly connect to that server. That target is 192.168.0.55. If I choose the Quick Connect button, you'll see that both the Quorum drive and the VM drive are currently available and have been discovered by the iSCSI initiator. If I choose the Quorum drive and choose Connect, that will actually connect to that Quorum drive. Same thing down here on the bottom with the VM drive. If I choose the Connect button again, I can connect to my VM drive and actually have a successful connection via iSCSI. Now you'll see here that we have two discovered targets, both of which we have currently connected to. We can choose to disconnect if we want down the road, or even further connect if necessary. We can view some additional properties of that connection as well. This is the identifier for that session, along with a little bit of information about that session. We also have additional portal groups that can be configured as well. You'll notice if you scroll through the various tabs here on the top of the iSCSI initiator, you want to make sure that the correct information is being displayed in some of these tabs. Under the Discovery tab, you'll see here that you can choose 192.168.0.55 over the port 3260. In some cases in your environment, you may want to install MPIO, or the ability to connect multiple adapters in to the same iSCSI target. In that case, you may not want to actually use the default adapter and the default IP address. Now, there is a strange behavior in the way that this screen is actually set up. In order to create your own custom portal, you'll need to choose the Discover Portal button and eliminate the existing portal that was created by default. If I choose the Discover Portal button and type in 192.168.0.55 and choose the same port number, and then select the Advanced button here, you'll see that I can choose a different local adapter, which in this case may be the Microsoft iSCSI initiator, and a different initiator IP. Perhaps I have a different IP address that's attached to the network card that I want to use. I can choose that as well. There is some additional information you can choose in here if you want to add in CRC checksums or actually enable CHAP login, more or less adding a password to that connection, which is a good idea for added security. You can choose IPsec as well in the second tab. But this is necessary if you want to go further with the customization of that iSCSI initiator configuration. In this case, I'm okay with the defaults, so I don't need to choose any additional information here. Under the Favorite Targets tab, it's very important that both of your drives are available here under Favorite Targets. You'll see the Quorum and VM targets are available to me. This lets me know that the iSCSI initiator is correctly connecting to those targets. On the Volumes and Devices tab, if I choose Auto Configure, you'll see that a set of information is brought forward that lets me know that I've indeed connected into those volumes. Once I actually go through and initialize those volumes, more information will appear here associated with the drive letter for those volumes. Now that we know we have all the information we need to have a successful connection between initiator and target, the next thing to do is actually go through and make use of that target. The first step in actually making use of that target is back here under Server Manager. You'll see here under the Storage node we have our old friend, the Disk Management node. Under the Disk Management node, I'm first going to remove the Actions screen here so we can actually see a little more of what's available here under the Disk Management node. Under the Disk Management node, you'll see that all of the different volumes that have been created for this server are available to us. This is no different than what we've seen before. Now down here on the bottom, you'll see these two drives that we've actually connected to as our iSCSI target. Now you'll see here's Disk 1 and Disk 2. It is currently unknown and offline. There's a couple steps that is required to actually bring this disk online. The first is to right-click on the disk and choose Online. This actually brings the disk online and makes it available for use. The next step is to actually initialize the disk by right-clicking on it once again. If I choose Initialize Disk, I can choose to initialize the disk as either an MBR or a GPT type disk. I can choose the disk I'm interested in and click the OK button. This initializes the disk but does not yet format the disk. The last step is to click on the disk itself and create a new volume on that disk. Because this is Windows failover clustering, we want to create a simple volume. If I choose the Next button here and use the maximum amount of storage space available, click the Next button again, I'm going to assign this the drive letter Q, because this is the small drive or the Quorum drive. If I choose the Next button again, I can choose to perform a quick format. Because this drive has already been created logically, there's no need to actually go through all the steps required for a full format. I'll call this the quorum drive for my drive label. If I choose the next button again and complete the simple volume wizard, you'll see that this begins the process of actually initializing that disk. While we're waiting, we can go through and do the second disk as well. We need to bring that disk online. We need to initialize that disk just like we did with the first disk. And then lastly, actually format the disk for use in our environment. I'm going to right-click here, choose New Simple Volume. The only difference this time being that the size of the disk is dramatically larger than the other disk. And I'm going to choose the drive letter F instead of the drive letter Q. This will be the drive letter that we'll use for the virtual machines. In this case, I will use the volume label VM. I'll choose the next button and finish, and you'll see it goes through the process of quickly formatting that drive. Once you've completed this process on the first server, the next step is to actually complete the process on the second server. Because there are two servers that are going to be involved with this cluster, this process needs to be completed on both the first and second server. You'll find that when you go to the second server, the elements or the parts in disk management are dramatically simpler because the second server should be able to be aware that the disks have already been formatted. Once this formatting process actually completes, we'll be able to begin using these disks to create a highly available cluster. If I go ahead and move this remote desktop out of the way, you'll see that we've completed two of the three steps involved with actually creating our cluster. The next step is actually configuring Windows failover clustering itself. If you're an IT professional with any history of actually working with Windows clustering, you probably remember some of the early attempts at Windows clustering and how difficult they were to actually create the cluster once you had the components in place. Well, with Windows Server 2008, the process of actually creating that cluster gets dramatically easier. You'll see here I'm pulling in a remote desktop to another server, so we can actually take a look at Server Manager and the Windows Failover Cluster Manager tool. You'll see here in Server Manager we're looking at the Failover Cluster Manager. And what we really want to focus in on is this Validate a Configuration Wizard. The Validate a Configuration Wizard actually makes the process of creating a cluster dramatically easier than in previous versions, because with this version most of the guesswork is taken out of making sure that you have all the configurations set up before you actually create the cluster. Back in the old days, if you didn't set things up perfectly and you went to create that cluster, you may not have actually created a completely well-functioning cluster. Well, with this Validate a Configuration Wizard, the process gets easier because the Validate Wizard will actually tell you if there are problems with your validation. If I click the next button here, you'll see that the first thing we need to do is actually enter in the server name for the computers that will participate in the cluster. There's Hyper-V 1, and here's Hyper-V 2. These are the two servers that we plan on actually making use of this cluster. And the tests that will actually be run by the Validate a Configuration Wizard will be done against both of these hosts to make sure that both hosts are ready to be part of a cluster. If I choose the next button here, we can choose which tests we want, or if we simply want to run all the tests, and check the next button. Once we check next again, we will actually go through the process of going through all of those validation steps. You'll see here that there are a number of validation tests that are actually done by the Validate a Configuration Wizard. I'll scroll up and show you all the ones at the top, and then scroll down and show you all the ones at the bottom. Now the goal here is for all of these tests to actually occur with this test passed. You can create a successful cluster if you have all passing. You can create a successful cluster if you have all passing with some warnings, but if you have anything other than warnings, you're not actually going to be able to create that cluster. Now the benefit of this wizard is if you have any warnings in your result from this validation, it'll actually tell you what you need to do to make sure that the cluster will complete correctly. Now, when you're actually going through this process of going through the validation, it is exceptionally important to watch to see what errors may occur. It is also required that a validation occur before the cluster can actually be brought online. Now this validation process can take an extended period of time. It may take between 5 and 10 minutes to complete all the tests. So I'm going to pause this recording, and when we come back we'll actually see a completed validation and start the process of creating that cluster. And we're back. You'll see that the Validate a Configuration Wizard has completed and brought forth a failover cluster validation report. It's gone through all the tests and provided us a report to let us know that testing is completed successfully and the configuration appears to be suitable for clustering. Now be aware also that when we actually take a look at this report, it has also found a couple of problems with the components that make up this cluster. It says here that while the configuration may be suitable for clustering, there are a number of warnings that should be addressed to obtain the highest availability. Now, if you remember before, I told you that a good cluster has a minimum of 3 interfaces, one for the public production network, one for the private network, and one at least for the iSCSI network. Now, I've purposely created this cluster so that we can see this error because I want to show you how the report looks when errors have occurred. I'm going to show you, if you click that report button, it'll bring forward Internet Explorer and show you an HTML file that gives you some more detail about what may have occurred with the cluster validation. You'll see here under networking we're showing a warning description. And if I click the network link, it'll drill me down to show me what part of that network component is actually showing the warning. Here it appears to be related to validate the network communication. If I click again, it provides me specific details about what may be going wrong with the validation. Validating that the servers communicate, that seems to be doing okay. It's pinged the network interfaces, and that's been successful on both servers. But you'll see down here in the bottom we have a couple of elements in yellow. These elements are warnings to let us know that we only have a single pair of interfaces that connect the 2 hosts to our shared storage and to each other. So while we can actually build this cluster as is, it's probably not a good idea to use in a production sense. Now, with this in mind, we're going to go ahead and build this cluster anyway, so you can take a look at what the process is for actually building that cluster. If I choose the Finish button here, you'll see that I can actually go and create that cluster from the same location that I previously validated its configuration. If I choose the Create a Cluster link here, it'll bring forward the Create Cluster Wizard. Now, the Create Cluster Wizard does a lot of the things that were done in the Validated Cluster Wizard, but it actually finishes the process by actually creating the cluster. If I choose the Next button here, I can enter in the server name for the servers that are actually going to participate in that cluster. In this case, it's Hyper-V1 and Hyper-V2. These 2 hosts successfully appear down in the lower box, which means that they are going to be able to participate in the cluster. Be aware that in order to get this far, the failover cluster feature must be installed to all of the servers before we actually begin the Create Cluster Wizard. If I choose the Next button here, I'll be given an option to choose what name I want to use when administering the cluster. In this case, let's call it Hyper-V Cluster. And I can choose what networks I also want that cluster to operate on. Now, every cluster needs a cluster address. I need to actually enter in a cluster address that's an IP address which will relate to the Hyper-V cluster name. In this case, let's use 225 because that's an available IP address on my network. If I choose the Next button, I'll have the option of confirming the selections that I've chosen for actually creating the cluster. You'll see that there really isn't a lot that we need to enter in to actually create that cluster. If I choose the Next button, it's actually going to go through the process of actually creating the cluster. Now, if at this point we had not done a cluster validation, it would have prompted us to actually complete a cluster validation. But because we've had a successful validation, it can actually go through the process of creating that cluster, creating the resource types, and doing everything that's necessary to create a healthy cluster. At the conclusion of this wizard, we will have a cluster that we can then manage and then actually integrate in with Hyper-V for the last step in this process. I'm actually going to drag this remote desktop away while it finishes the cluster portion so we can go back to our step-by-step screen. At this point, we've configured the StarWind iSCSI target software. We've attached those Hyper-V hosts to the target, and we've actually configured Windows failover clustering to create a successful cluster. The last step in this process is actually involved with configuring Hyper-V. Now you'll see if I drag this remote desktop back, you'll see that the cluster has been successfully created, and we can now manage that cluster from the Cluster Management Wizard. If I choose the Finish button here, you'll see that the Failover Cluster Manager feature now has a cluster that we can actually use to manage that cluster. All of the administration for this cluster is done within the Failover Cluster Manager tool. Now this is interesting. When you're working with Hyper-V, and especially clustered Hyper-V, you have to be aware that some of the components for managing Hyper-V will actually be in the Hyper-V Manager role, up here. Others will be down in the Failover Cluster Manager component. And so you'll need to actually split some of your administration roles between what's done in Hyper-V and what's done with Failover Cluster Manager. Now the first step that's required in creating a highly available virtual machine is done up here in the Hyper-V Manager. Let's actually expand Hyper-V and the Hyper-V Manager and actually take a look at the Hyper-V node here. Now what we need to do is first create a virtual machine. I'm going to right-click and choose New to create a new virtual machine. If you used Hyper-V before, this is really no different than the process you would do to create a virtual machine on a singular Hyper-V host. Let's call this VM1. Now what's different, however, is that we need to store the virtual machine in a different location. This default location for storing virtual machines is not on shared storage. This is not the StarWind iSCSI target that we created earlier on in this video. what we need to do is change the location to that iSCSI LUN. We do that by going up here to my computer, and we expand my computer to change it down to the VM drive. That's the F drive that we created before. That's the folder we want to create. This allows us to actually store that virtual machine in an area on a drive that can be talked to by both of the hosts that make up our cluster. If I choose the next button, I can assign the virtual memory that it's assigned to this virtual machine. I can assign any networking if I want. Here's a virtual network, for example. I can connect to a virtual hard drive, a single VHD file, and provide it a size. I can even install an operating system if I want. Let's assume at this point that I've already installed an operating system. In this case, I'm going to choose to install an operating system later. But you can assume that at this point you would actually go through and install an operating system for that virtual machine. Now, in order to make that virtual machine highly available, the virtual machine must be powered off inside of the Hyper-V Manager. The next step is actually to go into the Failover Cluster Manager and make that virtual machine highly available. If we go to the Failover Cluster Manager, and specifically to the Services and Applications node, we are actually going to create a new service or application called Virtual Machine. We do that by clicking the next button here, and scrolling down to the bottom and choosing Virtual Machine. Now this is going to change some of the options that we can see here on the left pane because we need to choose the virtual machine that we want to make highly available. You'll see here VM1 is the virtual machine that we wish to do that to. Its current status is off, and here's its host server Hyper-V1. In the next step, we confirm our selection, and it actually will configure this virtual machine for high availability. If everything goes correctly, we should get a success measure in the next screen. What this is doing is actually creating the cluster resources to make this machine highly available. You'll see that our virtual machine has successfully been created and is now highly available. We can now manage it from within our cluster. If I choose the Finish button, you'll see under the Services and Applications node I have VM1 that is currently offline. It is of type virtual machine, and its current owner is Hyper-V1. I can now choose to start the virtual machine, manage it, move it to a different node, for example, show critical events, or all of the different things that I would do with a standard service or application that I would create atop that cluster. So you'll see at this point, we've essentially created clustered Hyper-V. Your next step will be involved with actually creating the configuration within the Failover Cluster Manager for setting up the cluster however you want. Certain virtual machines you may want hosted on certain hosts, or you may want to configure failover or failback considerations. But really, this is the gist of what's involved for actually creating a clustered virtual machine using Hyper-V and the Failover Cluster Manager. So let's actually take a look at, once again, the steps that are involved with creating that clustered Hyper-V. Step 1 was configuring the StarWind iSCSI target software. Step 2 was actually attaching the Hyper-V hosts to the StarWind iSCSI target. Step 3 involved configuring Windows failover clustering, and Step 4 was involved with configuring Hyper-V and integrating the two pieces together. This is really the conclusion of creating that clustered Hyper-V. I want to talk a little bit about StarWind Software and some of the things that StarWind Software can provide for you. You know, StarWind Software is a software-based iSCSI target. It's like creating a SAN in your infrastructure without having to purchase an expensive hardware SAN. We say here that iSCSI SAN software is affordable network storage that can be used for clustering, for hosting of files, or really for any sort of storage that you need. StarWind provides a sense of storage virtualization through a number of the different features that it provides. Now, software-based iSCSI can be relatively useful in your environment. It has a large level of interoperability with universal, standard, and non-proprietary technologies. Because iSCSI works over your existing Ethernet network, you don't actually have to create a separate network for your storage. This is different than Fibre Channel, which requires its own different cabling, its own different networking, its own different routing, and all the different stuff that's involved with an entirely different medium for storage. iSCSI is also relatively easy to use for IT generalists, and so you, the IT professional, have a lot of freedom to use your existing and standard networking equipment without having to learn new technologies and new capabilities and all the different stuff that's involved with other types of SAN software. And best of all, software-based iSCSI works on any x86 or 64-bit server that has the Windows operating system installed. What this effectively lets you do is convert a Windows server into centralized network storage for really any application in your environment. The best part is that today's software solutions for iSCSI targets are reliable, they're scalable, they're fast, and they're affordable. Most importantly, they're very mature technologies and are going to be useful for you not only for your clusters, but also for all of your file storage needs. StarWind Software is a useful solution for a lot of different IT projects. Obviously, in this video, we've talked about virtualization, but it also is a useful solution for disaster recovery as well, allowing you to connect one SAN to another over a large wide area network for actually depositing information from one StarWind SAN to another StarWind SAN, such that if the original StarWind SAN actually has a problem, the other can take over for it in a disaster recovery scenario. This shared storage capability is useful as well for the Microsoft Windows clustering service, and provides a useful platform upon which to create high availability server clustering. So as you can see here, a StarWind software-based SAN is useful for most of your clustering needs. What's great about StarWind is that it also includes a lot of enterprise class features that you may not see in other software-based iSCSI targets. StarWind enjoys continuous data protection and snapshot features that provide an instant and point-in-time technology to recover individual files or folders or even an entire volume to some point in the past. This means that if for some reason you should delete a file or delete a folder or have corruption on a volume, you can very easily roll back that volume to a point in the past when that folder was there or before that corruption actually occurred. StarWind has mirroring and replication features as well that allow you to replicate mission-critical data using asynchronous replication and also synchronous mirroring across a WAN. Software-based mirroring, for example, RAID 1 and iSCSI replication, enable you to do entire volume or even entire site failover between two StarWind servers. It allows you to recover data in the case of a disaster so you can ensure uninterrupted storage operations. If you're familiar with some of the provisioning problems associated with virtualization, StarWind also allows you to do thin provisioning. What this effectively means is that when you provision software for StarWind, you're actually going to provision the storage for that software as that software requires the storage. This means that thin provisioning ensures that you only allocate as much space as required for the data that's being written on that volume. This prevents you from having an unnecessary level of waste on those volumes for just containing empty space. StarWind has other features as well. I/O RAID-write caching, NTFS compression and encryption for your compression and encryption needs. It has the ability to do shared volumes for cluster servers, as we talked about today. StarWind even has support for VSS, the Microsoft Volume Shadow Copy service. You can create RAM disks with StarWind or leverage it on top 64-bit or 32-bit architectures. For environments that require high levels of high availability, StarWind has support for MPIO, which allows you to connect multiple network cards in to ensure that you have no single point of failure in your environment. This is the same way with software RAID 1 mirrors and even with virtual tape libraries. So you can see that at an inexpensive price point, StarWind Software provides those enterprise class features for you that otherwise would require a hardware-based SAN at much greater cost. StarWind Software is available. If you want to take a look at www.starwindsoftware.com, you can take a look and download a free trial of StarWind's iSCSI target, and you can use it for creating your own cluster and your oown highly available Hyper-V architecture. There's some other information here, some phone numbers and some email addresses, but this gives you more or less the information you need to know in order to create that highly available Hyper-V infrastructure atop Windows failover clustering. Once again, my name is Greg Shields. I want to thank you for the opportunity to teach you a little bit today about how to create a cost-effective Hyper-V cluster using StarWind Software, Hyper-V, and the Windows failover clustering. Thank you very much.